Hello and welcome to our presentation on Advanced Design 2017, Bridge the Engineering and Drafting Gap. Advanced Design is an analysis and design software created by GRAITEC, which includes international design codes, such as American, Canadian, and Eurocode design. It is quick, simple, and flexible to use for modeling, and includes fast and powerful analysis. It is also interoperable with Autodesk Advanced Steel, making it part of a full BIM solution. It also has the capability of creating 3D climatic loads with its generator. In this presentation, we will visit Advanced Design and check out all its neat features. Here we'll get into the live portion of our presentation. We're going to explore the interface of Advanced Design and see the possibilities and functionalities. So we're going to show first the interface of what it looks like. We have our center, our visual graphic area where we can draw and create the geometry and the structure that we want here. On the top, we have our toolbars organized in a ribbon fashion and separated based on the functionality that we want. BIM for our import export, manage for our databases and other properties that we have. On the right hand side, we have our properties for everything in our visual graphic area. If we select one element, we can see all the properties that are related to this element. Even things like our supports, if we go and pick one support out, we could see their degrees of freedom that are blocked. And on the left hand side here, we have our project pilot, where we could organize and separate everything that we want in an organizational tree format with subcategories and subcategories. For instance, we have our subcategories for our supports here and for our purlins over here. And so this will allow us to go and select our elements as we want. And another interesting thing about our project pilot, as it's organized in an organizational tree format, we could simply double click elements to hide them as we want. So it also has a functional aspect to it. In the bottom, we have our command line, and our command line will be able to punch in values that we want when we're creating lengths of members, very similar to a style of AutoCAD, and they'll also give us errors in the process of launching our analysis and design. So this is the model that we're going to go in and create, and we're going to start off with our empty project here. So this is our empty project, and I've taken the liberty to go ahead and do some small things before starting off this presentation. The first thing I did is I organized my subcategories here, and we can see them added in here. And I've taken the liberty to also create myself two grids. My grid number one is in a gravitary direction, which will help me to draw out one of my faces of my structure. My second grid is a plan view grid, and so I could create as many grids as I want in each direction that I please. And we could see yet again, like I had explained, all the properties that go along with these grids here. We could see how they're defined in their X and Y local axis subdivisions for each one here. So what we're going to do is we're going to start off by modeling our structure. To model our structure, what we're going to do is put ourselves in a view where we could start drawing. I keep myself in an isometric view. I'm going to go in and pick out my linear element here. And once I select the linear element to draw out, it asks me what properties I want to define them. So things such as material codes, what are their cross sections, and other possibilities. Their releases, are they pin, fixed, what type of behavior we want as their end conditions, and other things that are related to the steel design of these elements. So deflection verifications, buckling lengths, lateral torsional buckling restraints, and things of that nature. So what we're going to do is we're going to keep this cross section that we have, a 10 by 30 with a steel material, and we're going to start off by drawing. And we have a lot of snap points that we could connect to. So we're putting in some W sections for our heights, and so I'm going to just draw out these simple geometry that we have, and we'll be able to go in and do any other modifications we want to them afterwards. And so I'm going to add in these members here, and they're slightly just a bit longer. What we're going to do is we're going to trim these here by using our trim functionality. So I'm going to change it for our cut, and it tells us to select the limitation entity and press enter. So I select my first one, I'll hit enter, and I'll come just a little in closer, and I'll trim this entity right here. And so now we have the reassurance that the members are properly connected. And we'll do the same thing very quickly off on this side here. Just zoom in a little, and we'll trim that section over there. And so we have our first facade already modeled out. And we'll carry on our modeling process here by adding in our extra elements here. And we could also add in our cross bracings while we're here. And so I am aware that my cross sections are probably not the best now, but there are also some other things that I need to correct in this model, and so we'll go and address them here. So we have our first part of our structure modeled here, and so we could see that currently we've been adding everything to the same sub folder, the subcategory. So what we'll go in and do is we're going to go in and modify these, and we're going to fix them so that they make some sense. So I have them here organized. So this will be, and you can see that we can easily just drag and drop these elements here. So in the beam section, here, and I'm just making sure that these elements are all in their right category, and with a simple drag and drop. So we could also select them while holding down our control option and making sure that they're all in the right one. And now this is where the fun portion really begins. What we can do is go and select our elements that we want to copy paste over. Just gonna make sure that I have the right elements selected. And I have my frame properly selected. I'm going to go copy paste them in this direction from here to here, and it tells us directly what the distance is. We could do a preview copy of that element, and we could even have some advanced options where I could send it to a specific destination of sub folder, and I'm going to send it to the tapered frame 1. I'm going to go in and I could do another option. So what I could do is change this for now from saying from here to that back portion. Well, I should rotate a little here, and I'll send it to tapered frame B. I could preview copy. I could continue doing that, sending them to their destination. I could also make them create new subcategories if I had not created those subcategories ahead of time. And then finally, I'm going to send the last option from here to here. And the fun part about this is that I wasn't obliged to close this dialog box. I needed to just go and select my different elements, and play with their frames. So I'm gonna just send it here, preview, copy, close. So I have my frames that are all set up here, and I could do some additional changes for these ones here. I'll do the same thing from here to here, and I could say, okay, well, I want it 3 times with a no option of that, and I could do preview. So had my distances been equal, I could have easily done that. What I'm going to do is I'm going to click close to come back. Select these 2 elements, and I'm going to hold control to replicate them on those here. And so I could do the same thing with these elements here. So one thing I'm going to do now is, now that we have our grid all set up, I'm going to hide this element here by selecting which elements I want to hide. I'm going to pick these out here, making sure I have the right ones, and I'm going to copy paste them over here. And so our structure is starting to come along in such a manner. So I'm going to add in a couple more members just to finish off the modeling process here, and then I'll show how to change some cross sections and create varying height, variable inertia, tapered members in our structure. So I'm just adding in some extra members, and I'm going to show how to also create some planar elements to be able to add loads on our planar element. We're going to continue by just modeling that mezzanine section. And we're going to make sure that the stat modes that we're using are the proper ones. So we're going to say intersection, perpendicular, not midpoint. And it's as easy as that. So you can see that the modeling process is very easy and quick. It's a lot like drawing. It's a lot like snapping end nodes together to create the structure that you want. And so to create or add in our planar elements, we're going to just make sure that we select the planar elements, and we go in and making sure that we're always in a view that we could pick out. We just do the contours, double checking that we have the proper materials that we want. So we have our different types of materials in here: concrete, ACIs, and we could go in and continue the modeling process. So it's important that we have these surface elements for the purpose of load application. And so that's a quick overview on the modeling process. I'm going to just finish off by showing the definition of tapered members, because the rest of it is very similar in the way we do things. And so we'll be able to change our cross sections here. So what we'll do is we'll go in and do some modifications to our cross sections. So for one thing, it's obvious that we need to change our X bracings. And so I could do this in a lot of ways. So I'm just selecting them one by one, but I could have done this a lot easier also. I know that these are all placed in the lateral bracing area here, and I could go and select them through this method here, and I could go and change them for whatever cross section. And so we have our databases here all the profiles that we need. And so we could go and pick out HSSs or flat bars. And I'm going to just pick out a square HSS. And we'll just say for now a very solid HSS. And we'll hit OK. And so we'll see them all change as we go. And the same thing happens for our beams. Everything that's a beam will be able to go and modify all together at the exact same time, and it'll save us time this way. And so some people prefer doing it this way. What I did is I modeled beforehand, and so what I'm going to do also is I could also limit by selecting. So what I could do is remove anything that's a planar element here to be able to select our beams a bit more efficiently, so that we don't have those other elements hiding behind. And so I have filter functionalities and sort functionalities here. So and I'm going to just turn it around so that I could select all these in one shot instead of having to select them all individually. And so we could go in like we had done for the other ones. We have different ways of selecting and modifying. So I'll just pick out here, and we can do the same thing for our columns. And so we'll pick them out in such a manner, and the same thing. So we could create parametric sections, and that's what I'm going to show you when we are going in to modify our tapered members. And so we've modified, and like I said, we have methods of sorting based on material or on cross section. So I could select everything that's a HSS, or I could select everything that is a W12 by 170, and it tells you the amounts in there. So there's a lot of sort functionalities. And so what I'm going to do is I'm going to start off by selecting this element here. We also have the possibility to drop down and change and play with the eccentricities and alignments. Why am I highlighting this? For the purpose of the import-export. When we're working with our model, sometimes the drafters like to align their members bottom fiber, as we could see here. If we're aligning it bottom fiber, sometimes we don't want to take these eccentricities into consideration. So here we can apply our eccentricities and define under the consideration of finite element meshing, define whether we want to take into consideration these eccentricities in the analysis or not. And so we could decide whether they want to be considered in this portion. And so what we'll do is we'll unclick it so that it's not considered in this finite element meshing, and and the drafters will be able to get their alignments properly, and the engineer will be able to do their analysis without having to consider these eccentricities, overcomplicating the model. So now we're going to define our member as being a variable beam, where we're going to change the start and end heights. So we're going to pick out an asymmetric I shape, and we're going to define its parameters, so all its properties, in a parametric way. And we could see it's a dynamic window where this diagram here will be automatically updated. So we're going to give the properties in terms of the heights, the flanges, and so I'm just putting in these dimensions of this member. So now the lower flange and upper flanges are different dimensions. and I'm gonna validate by clicking OK, and we'll see it update automatically. So that was for my start, and obviously this follows the local axes of the member. And now, because it saves all our other properties and keeps it a parametric, I need to only define the end height of my member if the rest of the properties, such as the flanges, are exactly the same. And now what I'm going to do is I'm going to reproduce the properties. What I do is match the properties. It tells us to select the target object, and then we apply it on the rest. And so we could see that because of the local axes, it's inverted. So I'm going to just select these members here and invert their start and end heights. And so now our beams are properly defined, and we're going to go and define our columns now. And so instead of doing a match properties, what I'm going to do is select them all and change them all one shot by selecting a variable height beam. And I'm going to start by selecting the first extremity to define it as an asymmetric like we had done with the other. And I'm going to go in and define its properties as we had done earlier. So I'm going to just put the start and all its properties in here. And I'm just going to give it some generic values to give an idea of what we can do here. So the start and the end. And obviously we're going to go and define its eccentricity. So we have one section that's we're going to need to modify. So what I'm going to do is I'm going to align it so that these guys are on this side properly defined, and I'll select these three here to go and rotate them by 180 degrees. So once the modeling portion is done, and so this we're gonna use this model to just apply some loads, but we get the general idea of how we can create a full 3D structure in there. The only thing I'm missing, which I will do right now, is selecting our elements to put a support at the base. And so this could be done in many ways. We have a lot of different types of supports, and so I'm going to just create a subsystem here, and I'm going to call it supports. And so what I'm going to do is select these elements that are our columns that will need these supports below them, and I'm going to right click and define it as a support selection, a rigid element, and then we could define, is it a pinned or a fixed? And so we'll go in here and select them. And so we could see them all being generated underneath the support one at a time. So now for the modeling portion is complete, we could go in and start defining our load cases. We could create one family of load cases or several. I'm going to create one load case family of dead loads. I have additional live loads I could put in. I could create snow loads and wind loads, seismic, temporal. We could also create some moving loads. And we also have, for these elements, wind and snow, climatic generators for different regions. And so I've defined my different load cases that I'd like to use, and we could see them here yet again in organizational tree format. We could change their name to being whatever we like. And there's also some parameters that are defined here for the climactic generators and other properties that are taken into consideration. And so what I'm going to do is I'm just going to bring back the whole structure so that we could use it in applying our loads. So we're going to filter out those grids again, and so we could go in and define dead loads and live loads. So we could take our loads and apply punctual loads, so concentrated loads, linear loads, and planar loads. And so I'm just going to show quickly how we would apply a planar load. I need to define a direction here. So in the X direction, we'll follow our global axis. So we'll put negative 100 pounds per square foot in the Z direction, and we could define it as being this portion here. And so we could see that we could also create trapezoidal. So I have it here depending on the coefficients. So now I have my load here, which is in my organizational tree here. I could select it. I could scale these if they're a bit too big. And obviously, we always have these grip points that we could go and create. And so it doesn't need to be always a square shape. We could do trapezoidal, triangular, any type of shape that we like. And so with these grip points, we could always change them and manipulate their place and how they're applied to our structure. And an interesting thing about these loads is that they're independent of the structure. We could go and move them and delete them, or we could delete the surfaces below them without having to worry about the load itself being deleted. Another interesting thing is that we could take these loads and replicate them as we had done with the other elements. So I'm going to just move these back, and I could take my load and do control and just reload them again. And I'm just moving that load over and using the grip points as I had done earlier. And so we have our load cases that are applied here. And if we wanted to apply our loads in that fashion, it's very easy, and we could do the same thing for wind loads. And so what I could do is I could just create a wind surface here that will be taking the loads, and so we could define it as being a unidirectional or a bidirectional, one-way or two-way surface, depending how we want to pass these loads off. And I could just easily right click and do load selection and change this here in either direction. So it'll be in my X direction, that's 20, and we have our load here. And so we could create all the possible permutations that we want there. To create our load combination is very easy. At the beginning of our modeling process, we need to define. So it's just telling me that I can't change codes in between my modeling process, but we can define the method of analysis in between. So that's grayed out. I would need to open a new project, but I'm just changing from ASD to LRFD for the purpose of creating our combinations. Now we do have a combination generator that will create all the possible combinations as defined by the IBC, and we can see how they're being combined here. Load 1 is our dead load, load 2 is our live load, 3 and 4 are in there also, and so it's creating the combinations as the IBC requests. So for this model, what I've done is that I've already launched analysis on the previous model, the completed model. So what we're going to do is we've created our model, we've applied our loads, and we've created our combinations. We're ready to launch a design and an analysis, and what we'll do is we'll go visualize our results right away. So what we can do is go hit the analysis button. we could say we could go in and check out our old analysis results, or we could create new ones and relaunch our analysis in design. We could do this, and we could do just a verification to ensure that things are okay in our model. We can mesh and verify that the finite element meshing and the structure is stable. Here we could do a finite element calculation for the purpose of seeing our internal results, and then we could launch some design results, some steel or concrete design results. So what we'll do is we'll go into consult our previous analysis results. So once we launch our design results or our analysis, or come back to consult our results like we just did, what we can see is that the toolbar automatically puts itself in the results toolbar. And this is contextual in the sense that if I would have launched a concrete design, we would have had some extra information here. So we have the possibility to visualize analysis results. So for instance, we have our displacements based on any one of our combinations, or just on any one of our simple loads that we've placed. So if we just do the self weight, we could pick it out and visualize the whole structure deformation in there. If not, we could always just go in and pick out a single element here. So I'm just going to pick out a we'll say, for instance, we'll pick out a tapered beam by going into our cross sections here and our tapered columns at the same time. If they're selected and we hit post processing, you can see that the results on just these elements are selected and nothing else. And so we could go in and visualize also displacements on, like I had said, on any one of the combinations. And here we could see them placed, or we could go and visualize forces, stresses on there also. So if I go pick out forces, this is for our linear loads. We have our different forces in here for our bending moment diagrams. So now I have just my my members that are selected, so we could see our bending moment diagrams on these elements here. So once again, I'm just going to isolate the rest of the structure, just these guys here. And so I could also filter out and say, okay, well, just display the results based on this combination on these forces. So we also have axial loads in any which one of the directions. We have the forces on any which one of the directions. So Fx, Fy, and Fz, Mx, My, and Z. So for rotations, or we could visualize no results and just check out. So these were for our linear elements. These are for our planar elements in here. And so, like I had said, we could see our bending moment diagrams. And so what we could always do is pick out one. We could always check out its results curves also. So we have some curves that are displayed here. So we have our Fz here for our axial loads, and we have our My for our bending load here. And it's easy to see that we have a lot of curves which display every combination and every every load possible. So we can easily double click, zoom in a little, and we have some other things that we can do. We could visualize just the graphical and export this to Excel. So we have every combination, but we could obviously send these to Excel and decide what we want to do with them later. If we don't want some of these results in there, we could select which curves we want to see. So if we didn't want any of these here, well, we could uncheck all or check all of them really quickly, and then we could go into the ones that are just for deflection criterias, for instance, and undo those guys there. So we're gonna just lighten up the diagram so it's not so heavy, and we could click OK. So we see that for instance, if we want to just see the ultimates in there and not see the deflection criterias, we could also display some points along the curve. Obviously we could zoom in and and see portions along that curve. We have the extremities here. We have the 0 points. So I'm just displaying. So the 0 points are where it's that graph. We could display some envelopes, and we could zoom in and out, and we could always save these curves also. So those are really just some of the analysis results that we can obtain. and some of the things that we can do. There's some other things that are interesting, and if I bring back the whole structure here, I'm just going to hide the static cases, the dead loads. So I'm hiding everything here. I'm also going to go up and hide my wind walls for that purpose. And also we have the results on our planar loads like we had seen before, so we could see the planar load results here. And so for our design results, we could visualize our design results here. So for instance, what I'm going to do is I'm going to isolate some of the members around them. So I'm going to just select my mezzanine beams. I'm going to hide everything else, filter everything else out, select them here, and we could see for instance deflection criterias or the strength, so the working ratios depending on which criteria we want. If we want the max bent working ratio, we could see how high these elements are being solicited, so their work ratio. We could easily see also suggested shapes. What are the suggested shapes? Well, they depict what the ratio is being used at for these elements. And if, for instance, some of these members were being too highly solicited, the work ratio was too high, well, advanced design would suggest a shape, and we could easily give a range. We could tell it to design up to 100%, but we could also give a lower range also, so we could say nothing below 50%, so that it's not being over designed incredibly. And so right now you could see that the worst case is this 69.4%, and we could visualize these based on sections, which these are all the same sections. We also could create design templates, which are groups of design, which I've done for these elements here. And so it shows you the element that is the worst, which is element 512. So we could see them here. So for instance, if I wanted to visualize these results in a spreadsheet or get a calculation note, we could easily, we're going to pick out that 512, which is this element right here, that is the most solicited, and we could go in and visualize what we refer to as a shape sheet. This is a design calculation note depicting the information on the member, its deflection criteria if we place one. So for this element, we placed just one deflection criteria of L over 360, and it presents the deflection criteria in a percentage, and as well as the calculation going through each clause and the percent of each one. And so we could go through them here, and we could see if they are less than or more than 100% for that. And better yet, we could get this, so this is just an overview of the results. We could get a more detailed report from this where it presents it in a different format. So it opens it up in Microsoft Word, and we could see all the information in here. So what type of information on the cross section, the deflection criteria, and then each calculation along with the chapter and clauses that is going through it in here. And so it shows the case numbers as well as the calculations and formulas that AD has obtained. And so we could save these for our results and use them later in a report. So what we'll do is we'll bring back the rest of the structure. Here, we'll hide our wind walls along with our loads. The last portion of this presentation I want to show before I get into the interoperability, the communication between advanced design and advanced steel, is the creation of a report. We have fully customizable design reports, and so there's some things that I'd like to show in the process of creating a report that are very neat features. So what we'll do is we'll come back to our modeling process, for instance here. And so what we do is we have the possibility to take saved views. For instance, we could take a saved view this way. We could also take some saved views. What we're going to do is we're going to hide everything but the main frames here. And so we're going to do, I'm going to remove these two here to show the tapered frames. And so I'm going to save another view, but we'll rotate it in the other direction, for instance. And so we could also take some saved views where we have things selected. And now a saved view, what it does is it allows you, there's several things that could help you do. It allows you to come back to that exact same moment in time. So here I have with all my wind walls in here, so I could rotate in the other direction. We'll take another saved view here. What we'll do is we'll apply also display our live loads here, for instance. So we could take another saved view and we could create a whole library of views that we could come back to use for the purpose of working. So I'll hide these ones and I'll display my dead loads. And so we could obviously rename these. And so easily what we can do is double click these views and it brings you back to that exact moment in time, but it's also saves what was selected in those, even things as simple as just removing the 3D frames. Well, we could do another saved view of that. So I'll just turn around and I'll show it of just these here, these ones here. I'm gonna filter out the rest. I had those other guys selected in the background. So we could have a view of just this frame here with, for instance, the grids, if we wanted to keep up the grids, or we'll have just these ones here and we'll save a view. And so we could always come back to that exact moment, and you see it puts it back in 3D. And so another interesting thing about these views is that what it'll do is we'll be able to use them in an analysis report or in a design report. So we're going to come back to our report project here. We're going to take one of our frames here and we're going to just hide the rest, select, and we're going to filter out so that we could get some post-processing results here. And we'll take for instance some we'll go into the results curve, and I'll take for instance this one here and I'll save this as a post-processing result, and we could see him here. And so once our views and our post-processing views are created here, so I could easily go back and do another saved view here of the forces. And what we can do is we could start by creating our reports. So we're going to go into documents, we're going to go into generate a report, and we could start by, I'm going to remove this, and we're going to start from a new fresh report, and we could start by creating with a cover sheet. We'll start with a table of contents, and we'll start with our first chapter. And our first chapter could contain things like the main model characteristics. And so always making sure that they're under the right subcategories, and then we could start putting in some views in there. So our first view, for instance, will be in there also, which will fall under. We could play with their alignment, and we could go in and continue with our chapter and put a section break, for instance, and follow it up with another chapter. And then in that next chapter we could have some tables or some design criteria. So for instance, we could go into steel analysis, results. We could do a shape sheet, for instance, and put in that shape sheet that we had before. And we could go and play with the properties in there. So shape sheet, which element is it that we're gonna go put in? And so we're gonna put it by design template, and we could decide which element we want. So we'll take the W beams, for instance, or any other elements in those shape sheets. And so we could go and continue and We could add in those curves, those post-processing views here, the forces in there, and we could add in other things as we want, and finally end it with a section break or page break. So that's how you go about, and we could obviously save these templates, these reports that we build as templates, so that we could come back and reuse them, or we could always load them afterwards once we've saved them. And so we could decide also which form of exporting do we want to send it to. We have different, send it directly to a PDF or to a text file or to a .x as I'm doing here. And I'm going to hit generate here. And so here we have generated report. I'm just going to stretch these elements out so we get the full information, and we have some information on my colleagues that I've put just as some generic information. We could put in our logos if we want, some information on the projects, and obviously then we have our table of contents in there, some information on the model with our screenshots or our saved views in there. So we have our shape sheet as we had seen for the design template of the W section, and we had, like we had seen before, the percentages that are being designed to, and some calculations in there. So some diagrams in there as we had saved it. And so we could go in and save our reports in that way. So that was the portion from A to Z in the modeling process, all the way to load application, to design results and reports. For this final portion, we're going to demonstrate how to communicate our model, take our model, Advanced Design, and send it to Advanced Steel for the purpose of detailing and for drafting, creating all the drawings as need be. So we're going to continue on with our Advanced Design model that we still have open over here. And we could see some of the cross sections that we were working with earlier, some W sections here, as well as some cross bracing HSSs, and obviously our tapered member in the background here, which we created by using a parametric section. What we're going to do now is, once we're done what we had seen earlier was our modeling process. We applied our loads in the modeling process as well. We created our load combinations. We launched an analysis. We verified its results and its design results. And now our model is complete, and we could send it to Advanced Steel for detailing. So what we're going to do is we're going to go into the BIM tab here at the top, and we can see that we have some other options for import export capabilities, but we're going to use what we refer to as our GRAITEC BIM send to Advanced Steel. So what we're going to do is we're going to do an export, and we're going to save it as an SMLX, and we're going to call it steel structure, and we're going to save it on my desktop in a pre-eng model AD import export. And we're going to save it as a steel structure and hit save. Now what we can do is we're going to go open up Advanced Steel so that we can do that import into our model. So we're just opening up the software here, and we have all our Advanced Steel capabilities, and we're going to go find the tab that says Export Import to go into that Advanced Import capability. We're going to go find our here our import export as we had seen, and we're going to go pull up our steel structure.smlx. And here we have our imported model into Advanced Steel, the finalized version. So we could see that we have our, I'm just going to double click our HSS here in the background. We have, so for our mezzanine section, if I just turn it around, we have our mezzanine section that has our W 18 by 175, and we had our 5 by 5 section, and obviously we have our tapered member in the background here. If I just open this up, we have all its definitions of its geometry. So now that we've imported, a user, an Advanced Steel user could go about and create his detailing and create his connections in this model. However, if there's changes that need to be made, what can happen? What can we do to create these changes or fix these changes? Well, we could always, I'm just going to save my model. We also have the possibility of creating or doing modifications in Advanced Steel and exporting it to synchronize back in Advanced Design, so that we're not having to recreate everything that we had. So what we can do is do some minor changes here to this. So what I'm going to do is I'm going to just pick out this member here, and I'm going to do 3 majority changes to it. I'm going to increase this member in such a way that we could really see it. So my first change was a modification. We're going to do a modification of a deletion to our X bracing here, and we're going to add in some members here to show an addition of a member. So and I'm going to change this cross section. Bear in mind, I am not the most avid user of Advanced Steel. And so we have an additional member here. So what we can do now is we've done the 3 major changes: a modification to our member, some deletions of cross bracings, and an addition, which would be the majority of our modifications. So what we're going to do is we're going to save the model. We're going to go into our export to export this model here. I'm going to give it a name, steel structure.smlx. And I'm going to save that model here. I'm now going to go into back into my Advanced Design model, where we can synchronize those changes. So we're going to go here into our GRAITEC BIM yet again and pick out synchronize instead of import, where we're going to go load the SMLX that we exported from Advanced Steel, where it will depict our modifications. We have 4 members that were deleted, showing a red marker. We have 1 member that was modified, showing a blue marker, and we could see we have 1 member that was added, showing a green marker. And so here we could go in and start deciding which elements we would like to accept or decline. We have filters where we could modify, where we could decide what criteria we want to determine is acceptable, and you don't need to select every one of them one by one. We could select all of them and hit the apply functionality. We would like to print a modification report for tracking. I'm going to hit simply no, and I'm going to hit yes. And so we'll give it just a second, and we could see our 4 cross bracings have been deleted. our single cross bracing here has been added with that 5x5 and 1/4, and our member here has been increased and beefed up to our 30x99, which we had done in advanced steel. And so this could be done in both directions. A user could, even an engineer who had noticed modifications were needed to his structure, can make those modifications and resynchronize back in advanced steel here. Or we could have done all this procedure in the opposite direction, where the drafter starts off the modeling to help the engineer save time, creates a generic model for the engineer to start sizing his members, and then the engineer, once is done doing his analysis and design as we had done, could export to synchronize back into advanced steel. And so there are many different workflows that one could use in optimizing. So that concludes our presentation. I really hope you enjoyed it and learned something about our software and our solution. We started off in the modeling process, applied some loads, visualized results, and then ended with bridging the engineering model with the drafting model to make sure that there are no mistakes. And so we have a lot of benefits. There are time saved with remodeling. There are less errors that are coming about it because the models are coming directly from the engineering model or from the drafting model, or vice versa. So I'd like to take time to thank you all for watching this presentation, and I hope you really enjoyed it.